Today I'm going to introduce a new amplifier technology. So this topology for the high-end audio can be a very good solution compared to any other topology exists. So I'm going to go through the introduction. First, I want to spend 1 minute to show a little video.
SSA technology inspires innovations. A beginning for a breakthrough. Elegant, stylish, passion for perfection. Pure enjoyment. It offers far more than what you see. Listen. SSA. Safari Hi-Fi delivers everything you can expect. SSA technology inside.
So what is the new technology? What about it? Okay, well, we're going to go through it. First, I would like to review a current topology for amplification to go through it, do some comparison. First, it's a very commonly used topology as Class A and Class B was invented in early 1900 until now. So next one will be the Class D technology. It's currently people knowing as switching power amplifier type topology. Probably it's so only three exist today for people show the product on floor. Probably all three of this. Okay. Let's talk about the Class A. We do some kind of review, very quick, go through it. We know we have Class A offer good sound, good fidelity for the sound reproduction. However, there's many drawbacks. Low power, large size, and very low efficiency. Transformer coupled, so a limited the frequency response. Also, the energy only can flow one side, one way. Then we take a look at the Class AB topology. Class AB offered higher power, but still very low efficiency. You see the big heat sink, fans, normally pretty heavy. It offers a good signal to noise ratio, but it's still big size. This is one thing affect the sound, which is crossover distortion. We know the Class AB need to set the bias. At a very low level, we can avoid the crossover distortion. As far as the energy flow, they only offer one direction. Now, this is Class D. Class D become popular after 1980s. Everybody use it. There are lots of chips available. People know if you want to achieve a small size, higher efficiency, that's probably the only solution. It has a higher power, good efficiency, good signal to noise, lighter weight. However, the sound quality is a question. People have a different view about the sound quality. Someone like it, someone do not like it. One of the problems for the Class D switching power amp still has crossover distortion. You can't avoid it. because the high-speed switch one or the other has to have a dead time to be able to prevent both switches turn on at the same time. And also one direction energy flow. That's about the current three very common topology exist. We're going to talk about the new our invention, which is called SSA topology, which is the single stage switching class A. I'm going to go through this in detail. What is a single stage? Which one is like a class A? How about compared to existing switching topology like a class B? First, this topology offers very high power, good signal to noise, much lighter weight than any other topology exists. Ultra high efficiency, much higher than class A. Class A, much higher than class AB. Also much higher than class D. I'm going to go through it. Why? This topology offered true audiophile sound quality because there has zero crossover distortion. No any rectifier stage in the topology. So we know the diodes only has one directional energy flow. In the amplifier, the conversion chain has no rectifier. No electrical, the big electrolytic cap, which is give you much longer lifetime. Small size. There is no any kind of, in terms of transient response. The cap is some of the problem for providing good sound. Then this amplifier topology offers true bidirectional energy flow. This is a very important concept. I'm going to go through it later on. Affect the sound quality we're hearing. The drawbacks is the circuit design is very complex. The higher components that count is not like a very simple class A, 1, 2, few components, one transformer. This is much more complex. Also difficult to control. Very complex to control. This kind of drawback for the new topology. Okay, we have we spent 6 years, very hard work from theory to production. We have already ready-made product in mass production. We have many patents, 25 patents for a while. Here's the simplified circuit to show you how the things work. First, we have unregulated DC power supply. It can be battery, can be whatever DC voltage has a large ripple, unregulated. Then we have a primary switch to drive our isolation transformer, because the isolation transformer is so important for safety. Then we have a pair of a bidirectional switch. And very important, the heart of this invention is a bidirectional energy tank to store the energy from either primary side or secondary side. Because we have a load impedance, it can be very inductive, like a speaker. Mechanical type of resonate circuits. The energy can come back, store in this part of circuitry, and determine if the energy too large, need to return to primary, we recycled to resupply to this load again. So this kind of simplified circuit. I just want to show everyone what's going on. Also, this circuit has multi-resonate system, the all parasitics resonate together to achieve the zero voltage and zero current switching to improve the efficiency. Okay, here's some main waveforms. You can see the old switches in the system working at a 50% duty cycle. That's the important concept. Because like a conventional class D working on the pulse width modulation, you have to have the daytime set up for all switches for the crossover distortion. For this method scheme, all switches work at a 50% duty cycle. There's no daytime. So from theory or from operational standpoint, it has zero crossover distortion. Has much better sound. Here's four very important equation dealing with the transfer function of the topology. We can see this. The output voltage, input voltage, which can be audio signal, the DC voltage, which is supply the energy. You can see very simple the linear relationship between input and output. Only determined as DC bus voltage and the high frequency isolated transformer return ratio determine the gain, also determine the output power. You see, the linear relationship has a very low distortion in terms of error. Here's an important aspect. I want to repeat this again. The bidirectional energy flow. Why important? Why people not addressing this? For example, the class AB, class A are commonly used for audiophile application. All those amplifiers are single directional energy flow. Very important. For example, we gave a speaker a pulse. When the voltage, the energy drives the speaker should move from electrical energy transfer to mechanical movement. However, when signal from whatever level back to zero, the speaker will not stop. The speaker still need to move because the leftover energy in the speaker system, then people from transfer to our sound quality, they become to less control, maybe the bass not tight. Because of this, also when the high power application, the energy is so large, can destroy the amplifier. In certain frequency, the energy becomes so large, the amplifier fails. That's one of the reasons. For this topology, we have a true bidirectional energy flow. The amplifier drives the speaker. When signal disappears, the energy returns to amplifier. 100%. Here is kind of measurement showing this effect. We have a class E amplifier. We have the SSA power amplifier. Both are in the same power level. 2 channels, 500 watt per channel. Then first, we drive 1/3 power sine wave, 170 watt per channel, and use resistance load. Then we have the measured data. We see at the same output, the SSA draw only 50% energy from the wall, from whatever AC line, 52%. Then we do another test. We use the true music signal, same signal drive both amplifier. Change the resistance load to speaker, true speaker, which is an inductive type of load. we see at the same power, same condition, this SSA amplifier draws only 43% of the energy from the wall. From here to here, we see 9% difference. Because of resistant load do not have the EMF energy, it's not inductor. So nothing come back. Soon as you change the load to speed, inductive type of load, the energy, additional energy will be circulating through the system. So we see additional 9% gain. As a result, from hearing point of view, you can hear very tight bass, very quick sound because of this. It's very important because before very few people address this issue because the conventional amplifier cannot do this. We always use some damping factor to measure a damping. That means how you will control the speaker. But now we have a new concept in terms of how speaker can be controlled. Here's a comparison that people always ask, what's the difference between this and Class D? First, Class D is opposed with modulation. Our topology uses phase modulation. Totally different. Switching method. Class D is a hard switching, which is a total sound switching. Much higher efficiency, lower noise, less radio interference. Then this topology has a true bidirectional flow, energy flow. Class D, the efficiency is higher. In this system, do not have DC power supply. To power this power amp, you do not need a power supply to set the bus voltage. Whatever higher or lower, this one do not have. There's no any rectifier stage, no any big electrolytic cap as the energy storage device. No, zero. The drawback, this is much more complex. So in terms of cost, it's higher than the traditional topology. So this is kind of curve, traditional distortion versus output power. You can see very consistent. Then we see the noise floor and multi-channel amplifier. There's no any kind of strange noise. Everything below, and there's no FFT below 130 dB. Again, here's using this technology. There's some final product is in production. In other words, this is not only something theory, or this has successfully designed, applied to real product. We're showing this at a newcomer's corner. Welcome anybody to stop by, listen to it, see how the technology going to affect our life. Any questions? Welcome for questions.